Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We have muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion because this is, after all, Ask the Expert, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker from BioGenes.
Hello everyone, I'm Jamina Fiedler from BioGenes. BioGenes was founded in Berlin, Germany in 1992 and is a provider for custom assay and antibody development as well as for analytical services. We are working for customers worldwide and are specialized on the development, validation, and production of host cell protein ELISA. That also includes the 2D Western blot analysis of the anti-host cell protein antibodies. BioGenes has been performing these services for several years now. Biopharmaceutical products have to be free of byproducts such as host cell proteins for their approval by authorities as the FDA. For that, a clear proof of sufficient HCP detection by the used HCP assay is required. The 2D Western blot method is the standard technique for the detection of HCP coverage. The colorimetric detection has several limitations that can be overcome by the use of fluorescent detection. Today I will explain how fluorescence improves the HCP detection analysis in 2D Western blotting. The first slide explains the main procedure of 2D DIGE Western blotting. Practical differences to the colorimetric procedure are the DIGE labeling of the sample prior application and the use of fluorescent labeled antibodies. All other steps as sample preparation, isoelectric focusing, SDS page, and Western blot transfer are equal to the standard colorimetric procedure. Here at our company, we work with the equipment of GE Healthcare. We use the gel size of 20 × 26 centimeters. The large gel size improves the resolution. The first advantage of fluorescence is the high sensitivity. This is very important if only small amounts of sample exist. The picture shows a Kumasi gel with 600 microgram on the left, parallel to a side-eye blot with 50 microgram on the right. Both show similar sensitivity, although the side-eye blot contains less than 1/10 of the amount on the Kumasi gel. The second advantage is the high dynamic range of the fluorescent method. All four pictures shown are visible range exportations of a single scan. The high sensitivity and the wide dynamic range of the side-eye fluorescence enable the detection of high and low abundant proteins. The evaluation software uses the whole information of the total dynamic range. Important for 2D Western blotting is this high dynamic range applies to the HCP pattern as well as to the antibody detection pattern. Therefore, it is not necessary to produce multiple blots with different intensities. The third advantage is overcoming intergel variation. The usual colorimetric procedure is running two gels using one gel for total protein staining with Gomassi or silver, shown on the left, and using another gel for Western blotting with immunostaining, shown in the middle. Intergel variation between the two gels makes spot matching necessary for evaluation. This can be very difficult, and unexperienced may do mistakes. The overlay on the right shows a typical intergel variation on which blue vectors demonstrate the spot pattern shift between the two gels. The first step of the new fluorescent procedure is labeling the sample with cyanide DIGE fluor minimal dye. Then running only one gel with subsequent Western blotting and immunostaining using fluorescent antibodies. This results in a 2D DIGE Western blot, on which the HCPs as well as the antibodies can be detected. The resulting advantages are, first of all, due to the elimination of intergel variation, no matching is necessary. Second of all, the transfer efficiency has no influence on the coverage determination. And third, 2D DIGE Western blotting makes the HCP detection evaluation easier and a complete electronic evaluation possible. Therefore, even gel distortions are no problem for evaluation anymore. In summary, the advantages of fluorescence over colorimetric detection are, first of all, the needed protein amount is far less. This is due to the high sensitivity. Second of all, the fluorescent method has very high dynamic range. Therefore, only one blot is necessary. Third, overcoming intergel variation. Not only one gel or blot is necessary. Also, there is no matching necessary, and a complete electronic evaluation is possible. Yes, well, thank you for listening. And now, before I answer your questions, in just a moment, I would be really happy if you could answer just 3 of mine.
So first, we'd like to ask the audience if you have practical experience in 2D Western blot analysis. And we see your answers coming up. Looks like a good number of you have responded. Thank you. Maybe just a second longer. Okay. The second question is, what technique do you use? Okay. And finally, do you perform this analysis in-house or by using an outsourcing partner? Okay, and now it's time for your questions. Are you ready, Jamina?
Yep, I'm ready.
So can you explain what is the pH range of the IEF-used strips?
Yeah, we use a pH range of 3 to 10. That's to give a complete overview over all of the pH range, which can be shown on a 2D gel.
Okay, and what software is used to determine the HCP coverage?
The software we use is the Image Master. from GE Healthcare. Our whole system is based on GE Healthcare.
Okay. And how is electroblotting accomplished without causing gel or membrane variation?
Sorry, can you repeat that, please?
How is electroblotting accomplished without using gel or membrane variation?
Yeah, membrane variation. I'm not quite sure if maybe I have to read the question. If it's just a word, in English that I just can't get along right now.
Okay, that's fine. We can follow up with a question later. What size was the gel then in your examples?
The size in the examples, we only use 20 times 26 centimeters, which is approximately 7.9 times 10 inches.
Does each exposure during the image capture reduce the intensity of fluorescence?
If I understood this question right, it's asking if it's obstructing the epitopes, or I'm so sorry. I don't know.
I think it has to do with how brightly the fluorescent is, and if you do it multiple times with that fluorescence, does it get lighter as you go on? But
oh, if it's like no. I can scan the membrane again and again. I mean, maybe after I haven't checked it if it gets less bright if I've scanned it 20 times. I have never done it as often, so to get a less fluorescence after some time, I store them in the dark so I can scan them like a month later again.
Do you find any difference between wet transfer and semi-dry transfer of the membranes?
Well, it's very difficult to do wet transfer on such a big gel. So actually, we haven't done the a tank blotting with these big gels. We've always done semi-dry blotting.
Sorry, we have a question about slide number 6, so I'll put it up. The question is, how do you calculate the sequence coverage of an antibody if you have areas of high saturation? One maybe.
Yeah, that's one. If you have, I think I understand the question. It's if I understand it right, you have areas where you have like very intense stainings where you're not even sure if you can see single spots, which you can see on slide 5 in the upper left area. So that's also a reason why we like to switch to fluorescence, because you need multiple, as I said, multiple blots to be sure that how the detection actually is to not have overstaining. So you would have to choose, for example, one blot with a low amount of antigen and a low amount of antibody, and a second blot with a high amount of antigen and a high amount of antibody, to have at least 2 different intensities to be able to evaluate this properly. So in fluorescence, you don't have this problem anymore because you have such a high dynamic range. You don't have a blur due to overstaining.
And I think we're going to wrap up the questions. There's a lot of questions. These will be passed on to Jamina to follow up with you directly via email, so you will get your questions answered. But the final question for the webcast is, does the fluorescent label change the 2D pattern?
No, it does not. The SciDi DIGE minimal labeling is designed by GE Healthcare, and it is promoted, and we haven't seen anything else, to not be changing the isoelectric point of a protein, and because of the labeling being so small, having no effect on the size of the protein.
Okay, well, thank you, Jamina, and thank you everyone for joining us. And we will have this available recorded, and we'll pass your questions along directly. Thank you so much.